In this slide, we talk about the linearity property of the Z transform. By linearity property, what we mean is that when we have the Z transform of Fn to f of Z, when Fn is sum of f1n plus f2n, we can actually take f1n, perform Z transform on it, f2n, perform Z transform on it, and add them up. This is equivalent to the Z transform of Fn. For linearity property, the sum must obey this law, as well as the second property, which is the scalar multiplication. When we multiply A multiplied by Fn, it is the same as the Z transform of A multiplied by Fn, or A times the Z transform of Fn, which is Fz. So how to prove this? It is by brute force. What you do is simply you just sub in, this is Fn, which is f1 plus f2. You open up the Z transform and you substitute f1 and f2 into the Z transform expression. We now distribute Z minus n into each one of these, because we can distribute in this sum. We then recognize that this is f1 of Z and this is simply f2 of Z. So we first prove the first property. To derive the second property, again we begin with A multiplied by Fn. We put in A Fn into the Z transform, and we realize that again we can pull out the A. When we pull out the A, we recognize this simply as A times f of Z. Therefore, these two properties are met. Actually, most of the time we use these two properties stated as a single equation, meaning that the Z transform of the scaled version of f1n plus the scaled version of f2n is the scaled version of f1z plus the scaled version of f2z. So Z transform is a linear transform, and we often use this property to simplify our analysis. Thank you.